Hi everyone, we're Mimicker, here to introduce all kinds of knowledge, even the stuff we didn't know about. And today, wow, we are embarking on a really fascinating deep dive. We're looking into a creature that perfectly embodies that phrase, beautiful but deadly. I'm talking about the blue-ringed octopus. Our mission today is to, well, unpack a really comprehensive report. It's titled Blue-Ringed Octopus, Deadly Pixie of the Sea.
Aptly named.
Definitely. We're going to pull out the crucial insights, debunk some myths that are actually quite dangerous, and hopefully arm you with knowledge. Knowledge to appreciate this, honestly, incredible animal, but also stay incredibly safe.
And it's more than just an interesting biological curiosity, isn't it? It really feels like an urgent blue alert from the deep. And for very good reason. We've seen these recent headlines popping up all over Taiwan.
Yeah, I've seen those. Penghu,
right?
And Tamsui.
Exactly. Penghu's tidal zones, the Tamsui's coast, even Hualien, a real surge in sightings of these tiny creatures. But here's where it gets, frankly, quite shocking. There have been documented cases, actual cases, of these lethal octopuses turning up in prepared seafood.
No way. In, food people are about to eat.
Yes, in prepared dishes. It just highlights this rapidly growing concern. What used to be a super rare encounter is becoming, well, a potential public safety issue.
Wow. Okay, so this deadly pixie, as the report calls it,
Yeah.
sometimes no bigger than a golf ball. Its increasing presence is maybe telling us something bigger.
Precisely. It likely signals significant changes happening in our oceans. It's a perfect, if alarming, example. Something tiny and beautiful hiding this incredibly lethal secret. And it really underscores why, when dealing with the natural world, knowledge is absolutely power.
Okay, so let's do it. Let's pull back the curtain and really unmask this deadly pixie.
Right. To really get a handle on this creature, we have to start with its scientific identity. It belongs to the genus Hapalocalina. That's within the broader octopus family, Octopusidae.
Hapalocalina. Does that name mean anything specific?
It does, actually. It comes from Greek words meaning something like soft tunic or soft skin, which, refers to its delicate body. A real contrast to its most famous feature, those vivid blue rings or stripes that scream danger.
And it's not just one single type of blue-ringed octopus, is it? I remember the report mentioning some diversity there.
You're right. It's a surprisingly diverse little group. Globally, scientists have confirmed at least 3 distinct species that are still around, extant species. And there's another one currently under study, so that number might even go up.
Okay, 3 confirmed, maybe more.
Yep.
What about specifically here in Taiwan?
That's where it gets particularly relevant for us. In Taiwanese waters, researchers have identified probably 3 to 4 species. This includes the greater blue-ringed octopus, that's Hapalocalina lunulata. It's a bit larger, more robust. Then there's the blue-lined octopus, Hapalocalina fasciata, as the name suggests. It has these striking lines instead of rings. And also the lesser or southern blue-ringed octopus, Hapalocalina maculosa.
3 or 4 species just in this area. That's more than I would have guessed.
And the picture gets even more nuanced. The report mentions specimens collected, for example, in Penghu that were labeled Hapalocalina CF maculosa.
Okay, what does the CF part mean?
Good question. CF stands for confer, which basically means compared to. It's a way scientists signal that, well, this specimen looks a lot like H. maculosa, shares key features, but they're not 100% certain it's the exact same species. It could be a really close relative, maybe a local variation, or, potentially even a brand new species they haven't formally described yet.
So like a scientific, looks like this one, but let's keep investigating. That's really interesting. Shows how much we're still learning.
Exactly. It really highlights the gaps in our understanding of their biodiversity. While we talk about 3 or 4 species locally, some broader studies hint there might be maybe up to 10 distinct species globally.
10? Wow.
Yeah. And each could have subtle differences, maybe in venom potency or behavior or where they prefer to live, things we just don't fully grasp yet. So getting that taxonomy right, that classification, is super important, especially now with climate change potentially shifting where these animals live and who they interact with.
And physically, we keep saying tiny. Just how small are they typically? We're talking thumbnail-sized?
Not quite that small, but definitely diminutive. Their arm span is usually under 15 centimeters. Some of the smaller ones, like H. maculosa, really are about the size of a golf ball, and they weigh next to nothing, maybe 26 to 28 grams.
Golf ball sized, weighing less than 30 grams, but packing such a punch. That's incredible.
It really is. Their body is mostly soft tissue, very pliable, except for their beak. It's like a parrot's beak, quite hard. And that's what they use to actually deliver the bite. And of course, they have the standard 8 arms lined with suction cups used for moving around, grabbing prey. And those famous blue markings, though, well, they're not always visible.
Right, that leads perfectly into their most intriguing feature. Those blue rings aren't always on display, are they? Which ties into their deceptive appearance.
Exactly. Normally, their resting color is pretty unremarkable. A dull brown, maybe a yellowish brown. This lets them blend in incredibly well with rocks, sand, algae, just disappear.
Camouflage. Makes sense for a small creature.
Absolutely. It's crucial for their survival, but it's also crucial for us to understand why they're often missed or mistaken for something harmless. They're masters of disguise.
Okay, but then the transformation happens.
Yeah.
Here's where it gets really interesting, right? When they feel threatened.
Yes. This is the dramatic part. When they're provoked or feel cornered, that dull camouflage vanishes instantly. Their skin rapidly darkens, almost to black sometimes, and simultaneously those patterns erupt. They become these vivid, iridescent blue or blue-green rings that seem to almost glow.
Like flipping a switch. A very scary switch.
It's an incredible biological light show, but it's sending a very clear, very deadly message. Back off.
How do they do that so quickly? Is it like ink or?
Not ink, it's much more sophisticated. Their skin has layers of specialized cells. Near the surface are chromatophores. Think of them like tiny sacs of pigment brown, yellow that can stretch open or squeeze shut really fast, controlled by nerves, like pixels on a screen.
Okay, so that handles the basic color change. But the blue glow.
That comes from deeper layers containing iridophores. These aren't pigments. They're like microscopic stacks of reflective plates. Tiny mirrors, basically. They're tuned to reflect specific wavelengths of light, in this case, blue and green.
So when it gets scared?
It contracts the chromatophores, pulling the dull brown pigment layer back, almost like opening tiny curtains, and bam! This instantly reveals the iridescent blue iridophores underneath, making the rings flash and appear to glow. It's this dynamic interplay of pigment and reflection.
Wow. So it's not actually producing light, just reflecting it in a really dramatic way when the brown curtains open?
Precisely. It's incredibly efficient, both a survival tactic and a form of very clear visual communication.
And this type of warning coloration has a name, doesn't it? Aposematism.
That's the term, yes. Aposematism, warning coloration. Think of poisoned dart frogs or some venomous snakes. They're often brightly colored all the time.
Right, they advertise their danger constantly.
But the blue-ringed octopus is maybe a bit more strategic or maybe just energy efficient. It doesn't waste energy being bright blue all the time. That might attract unwanted attention from predators who aren't deterred by the warning anyway. Instead, it stays hidden. It only shows its cards, flashes those warning colors when absolutely necessary. It reduces risky physical encounters. Predators learn fast. Flashing blue equals extreme danger. Stay away.
It's a masterclass in risk management, really. Nature's flashing neon danger sign, but only turned on when needed.
Couldn't have put it better myself.
It's so clever, that on-demand system. Has it actually inspired any human technology? It feels like something we'd want to copy.
Oh, absolutely it has. Researchers are fascinated by it. Its skin's ability to rapidly change color and reflectivity has influenced quite a bit. Things like developing biodegradable display screens, imagine flexible screens that work on similar principles. Also, adaptive camouflage for military use gear that could potentially change color to match its surroundings instantly.
Like the octopus blending in.
Exactly. And even things like smart windows that could adjust their tint or reflectivity on demand. It really shows how nature often has these incredibly elegant solutions to complex problems. We learn a lot by studying creatures like this, even the dangerous ones. Hashtag tag habitat, lifestyle, and life cycle.
Okay, so from that dazzling, terrifying display, let's look at its everyday life. Where does this potent little creature hang out?
They have a pretty wide distribution, mainly along the coasts of the Western Pacific and the Indian Ocean. Think from southern Japan down through Southeast Asia, Philippines, Indonesia, and all the way south to Australia, where they're quite well known.
And their preferred hangouts, are they deep sea or?
No, typically shallower coastal waters. They love complex environments where they can hide. So coral reefs are prime real estate. Rocky seabeds, too. Tide pools are a classic spot. Also, seagrass beds, areas with lots of algae. Basically, anywhere with lots of nooks and crannies for hiding and ambushing prey.
And reminding everyone again, the specific spots in Taiwan where they've been increasingly seen.
Right. The key areas mentioned are Penghu, those intertidal zones especially, also along the northeast coast and down in Hualien as well. So definitely areas where people might be exploring the shore or fishing. Awareness is key.
And their daily schedule. Are they sunbathers?
Definitely not. They're primarily nocturnal, night owls of the sea. During the day, they stay hidden, tucked into crevices, burrowed under sand. Sometimes even inside discarded bottles or cans, human trash can become their home.
So they use our junk. Interesting.
They do. Then, as night falls, they emerge to hunt.
And how do they hunt? Do they chase things down?
Mostly ambush predators. Very patient. They'll sit camouflaged, waiting for something tasty to wander by. Small shrimp, crabs, maybe a small, unwary fish. They use their arms sometimes to kind of corral the prey, block its escape. Then, lightning fast, they deliver that venomous bite with their beak. It paralyzes the prey very quickly. Then they consume it. Efficient.
Efficient and deadly. And their lifespan. Do these powerful creatures live a long time?
Surprisingly, no. Their lifespan is quite short, relatively speaking, typically only about 1 to 3 years.
Really? That seems short for something so potent.
It does, doesn't it? And what's fascinating here really highlights their life strategy is their reproduction. Females only reproduce once. They lay a relatively small batch of eggs, maybe around 50 or so, and then begins this incredible act of maternal care. She guards those eggs constantly, tucking them under her arms, protecting them.
For how long?
For about 6 months. And during that entire time, she doesn't eat. She dedicates all her remaining energy to protecting those eggs.
6 months without food. Wow. That's dedication.
It's an immense biological cost. And tragically, but perhaps necessarily for the species, shortly after the eggs hatch and the tiny octopuses disperse, the mother dies. Her life's purpose fulfilled, her energy completely spent.
A real sacrifice.
Absolutely, a one-shot strategy. But here's another incredible adaptation related to that venom.
Oh?
The venom, the TTX, is actually passed into the eggs.
So the babies are venomous right from the start.
Yeah, exactly. The hatchlings emerge already equipped with their primary defense mechanism. In a dangerous ocean full of predators, being born toxic gives them a fighting chance. It's a remarkable evolutionary trick.
Okay, so tiny, masters of disguise, dedicated parents. But the core reason for this deep dive, the blue alert, is that venom. Let's get into the details of tetrodotoxin, TTX.
Right, this is the chemical behind the lethality, tetrodotoxin, a neurotoxin. But here's a really crucial point that often surprises people. The octopus doesn't actually make the toxin itself.
It doesn't. Then where does it come from?
It comes from symbiotic bacteria, tiny microorganisms like certain species of Vibrio bacteria that live inside the octopus's salivary glands. The bacteria produce the TTX, and the octopus essentially harbors them and utilizes the toxin they produce. It acquires it.
So it's like outsourcing its weapon production to resident microbes.
That's a great way to put it. It means the octopus gets the toxin from its environment, indirectly, or maybe through its diet as well, accumulating it.
Does that mean the amount of toxin can vary? Like some octopuses might be more dangerous than others?
Precisely. Because it's acquired, the concentration isn't fixed. It can depend on the specific bacteria present, the octopus's diet, its age, the local environment. Lots of factors. And critically, the toxin isn't just in the saliva or the bite. It's distributed throughout the octopus's body.
Where else?
Arms, abdomen, mantle, internal organs. Even the ovaries can contain TTX, which means just handling one, or heaven forbid, eating one, is incredibly dangerous, not just the bite.
Okay. And just how potent is TTX? We hear deadly, but can we quantify that? The report had some scary numbers.
Scary is the right word. The potency is truly staggering. By weight, TTX is estimated to be anywhere from, say, 20 to 50 times more toxic than cobra venom.
Wow. More toxic than a cobra.
And compare it to cyanide. It's over 850, maybe even up to 1,200 times stronger than potassium cyanide.
That's almost unbelievable.
And here's the statistic that really drives it home. A single small blue-ringed octopus, potentially one you could hold in your palm, can carry enough TTX to kill roughly 26 healthy adult humans.
26 people.
Yeah.
From one tiny octopus.
Within minutes. It consistently ranks right up there, often in the top 3 of the world's most venomous animals.
Okay, so even if the exact amount varies, the bottom line is assume any blue-ringed octopus is lethally dangerous.
Absolutely. While toxicity can range from technically undetectable in some rare cases up to very high levels, like 174 micrograms, you simply cannot tell by looking. The only safe assumption, the only rational approach, is to treat every single one as potentially deadly. Never, ever take a chance.
Right. Let's unpack why it's so dangerous. What does TTX actually do to the body? This raises an important question about the mechanism.
It's a neurotoxin, so it targets the nervous system. Specifically, it works by blocking something called fast sodium ion channels in nerve cells.
Sodium channels. Okay, what do those do normally?
Think of nerve signals as electrical messages. For those messages to travel along a nerve fiber, tiny gates, the sodium channels, have to open and close rapidly, letting charged sodium ions rush in and out, creating an electrical pulse.
Like flipping switches along a wire.
Exactly. TTX is like a key that perfectly fits into those sodium channel locks and jams them shut permanently while the toxin is present. So no ions can flow, no electrical signal can pass. It effectively shuts down nerve communication throughout the body.
A complete communication blackout. So messages from the brain just stop.
They stop reaching their targets. The devastating result is paralysis. Muscles stop receiving signals to contract. Interestingly, the heart muscle uses slightly different channels, so it's often less directly affected initially, though heart problems can occur later. But the muscles you use to breathe, they rely heavily on those sodium channels.
So you can't breathe.
Respiratory failure is a primary cause of death. The diaphragm and other breathing muscles become paralyzed. And here's the truly chilling part. Because TTX doesn't easily cross the blood-brain barrier, the victim often remains fully conscious, fully aware, while becoming completely paralyzed.
Oh my God. Conscious but unable to move or breathe? That's horrifying.
It's an incredibly distressing experience, trapped inside a body that won't respond. This is why immediate and continuous artificial respiration is the most critical intervention. Even if they seem unresponsive, their mind might be perfectly lucid.
Okay, that underscores the urgency. So what are the symptoms someone might experience after a bite? How quickly do they appear?
Symptoms onset usually very rapidly. We're talking minutes, maybe up to 15 minutes, sometimes a bit longer. It often starts subtly. A tingling or numbness around the lips, maybe the tongue. This can spread to the face, then the fingertips and toes.
Numbness, okay.
Then muscle weakness sets in, often starting in the limbs. Difficulty swallowing, slurred speech are common. And then the critical stage, respiratory distress. Shortness of breath, difficulty breathing, leading to cessation of breathing. Other possible symptoms include nausea, vomiting, dizziness, maybe an irregular heartbeat, changes in blood pressure, and pupils might become constricted.
And the most critical question, is there an antidote? Can doctors reverse this?
This is vital and stark. No, there is currently no known antidote for tetrodotoxin. None. Treatment is entirely supportive. It's about keeping the patient alive until their own body can metabolize and get rid of the toxin.
So it's a waiting game, basically, while machines keep you alive.
Essentially, yes. The absolute cornerstone is respiratory support, keeping the patient breathing, often with a mechanical ventilator in a hospital. This lack of an antidote makes prevention absolutely paramount, especially in remote areas without quick access to advanced medical care.
Okay, so if the worst happens, someone is bitten. What are the absolute, immediate, critical first aid steps?
Okay, 3 key things. 1, apply pressure. Immediately put firm pressure on the bite wound, maybe using a pressure immobilization bandage if you know how, like for a snake bite. This aims to slow the toxin spread into the bloodstream.
Pressure on the wound, got it.
2, and this is the most crucial, artificial respiration. If the person shows any sign of difficulty breathing or stops breathing, start rescue breaths immediately, mouth to mouth, or use a bag valve mask if one's available. And you might need to keep doing this for hours, literally hours, until professional help takes over or they reach a ventilator. This buys critical time.
Continuous breathing support, absolutely vital. And third,
get medical help immediately. Call emergency services, get the person to a hospital as fast as humanly possible. They need advanced life support. The positive side is, if a victim survives the first 24 hours, usually thanks to effective respiratory support, their chances of making a full recovery are actually quite good.
So surviving that first day is key.
It is, but it's also really important to note children are at much higher risk. Their smaller body mass means the same amount of toxin has a much more severe effect.
Knowing how incredibly dangerous this is, being able to identify it becomes just crucial, especially with these reports of it ending up in seafood. So what does it look like live versus dead? And why is that difference so confusing and dangerous?
This is a major public safety point. Live, as we said, it's usually dull yellow-brown when calm. But when threatened, bam! Those dozens of iridescent blue rings flash brightly against darker skin, unmistakable if you see it happen.
But that camouflage, the challenge you mentioned, they don't always flash those rings.
Exactly. When calm or hiding, it can look incredibly plain. Just a small brown octopus. Easy to miss, easy to mistake for something common and harmless. People pick them up out of curiosity, thinking they're cute or just another octopus. This dynamic appearance is why the rule has to be. If you don't know exactly what it is, don't touch it. Period.
Never handle unfamiliar sea creatures. Got it. But the problem gets worse after they die, right? The post-mortem confusion the report talks about.
Yes, this is a huge risk factor, especially concerning seafood. After the octopus dies, those amazing blue rings, which rely on living cells and nerve control, completely fade away. They just revert to a dull brownish color. Sometimes the pattern might be faintly visible as slightly darker spots, but nothing like the vibrant blue.
So a dead blue-ringed octopus looks just like a regular small brown octopus.
Pretty much, yes. They become incredibly easy to mistake for common edible species, especially the smaller ones often sold in batches. This is believed to be a primary way accidental poisonings happen through consumption. Fishermen might catch them accidentally, vendors might buy mixed batches, and nobody recognizes the danger because the warning sign is gone.
That's terrifying. It highlights the need for awareness all along the supply chain, doesn't it? And for consumers.
Absolutely. Education for fishermen, vendors, and consumers is vital. Plus, potentially better inspection regulations.
Okay, so let's get practical. How do we distinguish them from the safe, common, edible species we see in Taiwan, like Octopus minor, short-arm octopus, or Octopus ocellatus, ocellated octopus? Okay, let's unpack this carefully.
Right, knowing the differences is key. The common edible types like minor and ocellatus typically have only one or sometimes two circular markings. And critically, these markings are usually golden or yellowish-brown, not blue, and they're often located near the eyes. Think distinct, isolated spots.
One or two golden spots near the eyes for the safe ones.
Yes.
And the blue-ringed.
When it's showing its colors, the blue-ringed is covered in numerous distinct blue or blue-green rings, or sometimes stripes or irregular spots. Not just one or two, but dozens, all over its body and arms. That's the major visual difference when live and displaying.
So lots of blue rings or spots equals danger.
Got it.
Even if they're dead and faded, should we look for faint patterns?
If you see any octopus, especially a small one, at a market that has numerous, somewhat regularly spaced darker spots or rings, even if they're brown, be extremely suspicious. Assume it could be a faded blue-ringed octopus and do not buy or eat it. The safe species generally look uniformly brownish-gray after death, without that kind of spotted or ringed pattern.
Okay, let's quickly recap the key comparison points from the report for clarity. Size.
Blue-ringed or small, golf ball up to maybe 15, 22 centimeter arm span. Common edible ones are similar, sometimes slightly larger, but size alone isn't reliable.
Live appearance.
Blue-ringed. Brown-yellowish, flashes vivid blue rings when threatened. Common. Brown-grayish, no blue rings, maybe one pair of golden spots near eyes. O. ocellatus.
Reaction when provoked.
Blue-ringed, skin darkens dramatically, blue rings glow brightly. Common. No major color change like that, might ink or flee.
After death. This is the crucial one for food safety.
Blue-ringed, rings fade to brown spots rings, easily mistaken. Common. No distinctive marks, just brownish-gray. Blue-ringed, extremely toxic. TTX. No antidote. Common. Non-toxic, safe to eat.
And habitat distribution reminder.
Blue-ringed. Western Pacific Indian Ocean coasts, reefs, tide pools, increasing in Taiwan, Penghu, NE Coast, Hualien. Common. Widely distributed in coastal waters, common catch in Taiwan.
That comparison is super helpful. The key takeaway seems to be lots of blue rings, live, or lots of suspicious faded spots rings, dead, means danger.
Exactly. And understanding these differences feeds into how we can coexist safely. It's vital to remember, despite being so deadly, these octopuses are not aggressive.
Right, they aren't actively hunting humans.
Not at all. They're shy, they prefer to hide or escape. Almost every single case of a human being bitten happens because someone accidentally steps on one. Or more often, someone picks it up. Out of curiosity, maybe because it's small or they want a photo, it's almost always human behavior triggering a defensive bite.
So respect and distance are the best policies. Don't judge by appearance.
Precisely. When you're at the beach, exploring rocks, wading in tide pools, be alert. Look where you step. Look where you put your hands. And never, ever touch marine life you don't recognize. If you see an octopus with blue rings, admire it from afar. Don't try to handle it. Don't poke it.
And for fishermen.
If you accidentally hook one, the advice is clear. Cut the line. Don't try to bring it aboard or unhook it. Just let it go. It's not worth the risk.
Okay, and the biggest don't for everyone, especially relevant to those seafood market stories.
Never, ever eat a blue-ringed octopus under any circumstances, and this is critical. Cooking does not make it safe.
Why not? Doesn't heat destroy toxins?
Not this one. Tetrodotoxin is extremely heat-stable. Boiling, grilling, frying, stewing, none of it neutralizes the poison. It remains just as deadly after cooking as it was before.
That's a crucial piece of information. Cooking offers zero protection.
Zero. And it leads to another serious risk. Cross-contamination.
How so?
If you unknowingly cook even one blue-ringed octopus in a pot with other safe seafood, the TTX can leach out into the cooking water, the broth, the oil. This can contaminate the entire dish. Everything in that pot could become lethal, even the pieces that were originally safe.
Oh, wow. So if you find one after cooking.
Discard everything. The entire pot, all its contents. Do not try to pick out the good pieces. The risk of the whole meal being toxic is too high. Just throw it all away.
Okay, so for consumers buying octopus, what's the absolute golden rule?
Inspect carefully, especially small octopuses. Look for those faded ring patterns or spots we talked about. If anything looks unusual, unfamiliar, or suspicious in any way, don't buy it. Don't eat it. The golden rule is simple and potentially life-saving. When in doubt, leave it out.
When in doubt, leave it out. Good rule to live by. Now, inevitably, with something this scary, myths pop up. What about things like drinking milk cures the poison?
Ah, yes, the milk myth, and other similar home remedies or folklore cures. These are incredibly dangerous. Toxicologists, medical professionals, they are unanimous. These things do not work. There is zero scientific basis for them.
So not only useless, but harmful.
Exactly, because relying on a myth, trying some useless home remedy, wastes precious time. Time that should be spent getting the victim proper medical help specifically, respiratory support. Delaying that help can be fatal.
So fighting misinformation is as important as the first aid itself.
Absolutely. In any poisoning situation, rely on scientific facts and expert medical advice. Get to a hospital. Don't trust random online claims or old wives' tales. Critical thinking and prompt medical care save lives here.
This whole situation, the increasing sightings, it feels like points to something bigger, doesn't it? The report links this to climate change.
It does. Historically, blue-ringed octopuses were more common further south, near Australia or maybe Japan. They weren't really a common sight in places like Taiwan or in Chinese fish markets historically.
But that's changing now.
It seems to be. Their increasing presence in Taiwan is a real concern, and experts strongly suspect climate change, particularly ocean warming, is a major driver. As the oceans get warmer, the water temperature zones are shifting. Areas that were previously too cool for these octopuses might now be becoming suitable habitats. They're essentially expanding their range northward, following the warmer water.
So they're moving into new neighborhoods because their old ones are changing or the new ones are becoming more comfortable.
A bit of both, likely. And if we connect this to the bigger picture, well, it's not just about this one octopus species. It's a sign of much larger ecological shifts happening globally. Species are moving, invading new territories, changing migration patterns. This can disrupt existing ecosystems, introduce new predators or toxins, and create unforeseen public health risks, all linked back to rising temperatures.
So the blue-ringed octopus is kind of like a canary in the coal mine for our oceans.
That's a very apt analogy. Its appearance in new areas serves as a clear ecological warning sign. It signals the urgent need for global climate action, for reducing emissions, and it also highlights the need for much better long-term monitoring of our marine ecosystems. We need to understand how things are changing to adapt and mitigate the risks, both ecological and to human safety.
It really puts it in perspective. This tiny creature carries this huge message, and despite its danger to us, it does have its own place in the ecosystem, right?
Absolutely. We focus on the danger, understandably, but the blue-ringed octopus plays its part. It's a predator controlling populations of small shrimp, crabs, fish. It helps maintain balance and biodiversity in its habitat. Its venom isn't just a threat, it's its tool for survival, for finding food, for defending itself in a tough environment. It's a product of evolution doing its thing.
What about its conservation status? With sightings increasing in some areas, is it considered threatened or?
It's a bit unclear, actually. The IUCN, which assesses conservation status globally, lists most Haploclina species as not evaluated. Basically, there isn't enough data for a proper assessment.
So we don't really know their overall population trends.
Not definitively on a global scale. Interestingly, though, Taiwan listed it as a Category I protected species way back in 1992. Now, that was likely driven more by the public safety risk acknowledging how dangerous it is rather than concerns about it being endangered at the time, but protection is protection.
Is there any threat to them besides natural predators?
Well, like many unusual marine creatures, there is some unregulated collection for the aquarium and pet trade. That could potentially put pressure on local populations, even if the species overall isn't listed as endangered.
So it really comes down to our collective responsibility, doesn't it? How we interact with the ocean environment as a whole.
It really does. It starts with improving our own knowledge, our scientific literacy, learning to identify potentially dangerous creatures like this one so we can stay safe. It means fostering respect for all marine life. Admire from a distance, don't touch, don't capture, leave wildlife wild.
And our choices matter too, right? Like with seafood.
Definitely. Supporting sustainable fisheries, choosing seafood that's caught responsibly, helps protect the entire marine ecosystem, including the habitats these creatures rely on. And overarching all of that is the need to act on climate change, reducing our carbon footprint, advocating for policies that protect our oceans, because ultimately the health of their world is tied directly to the health of ours.
It's fascinating. By taking the time to understand something like the blue-ringed octopus, its beauty, its danger, its role, even the warning it carries about climate change, we do more than just protect ourselves. We gain a deeper appreciation for how incredibly complex and interconnected life in our oceans really is. And maybe that knowledge, that respect it fosters, maybe that can empower us to coexist more peacefully, even with creatures that seem dangerous, and work together for a marine future that's sustainable and thriving for everyone.
That's the hope, isn't it?
It makes you wonder what other hidden pixies are out there in the natural world, waiting for us to understand them better, waiting to share their secrets, maybe their warnings.
A thought-provoking question indeed. There's always more to learn.
Thanks for tuning in to this deep dive. If you enjoyed our content, don't forget to like, subscribe, and turn on the notification bell.